Uh, Good afternoon to all course participants. In this course, this is the fourth lecture where I will discuss land use planning in watershed and soil and water conservation measures which are recommended or being adopted in the watershed management plan. If we see, watershed development program primarily focus on conservation of natural resources. Means soil and water is one of the basic natural resource which is required for human life and all biological activity. So conservation of soil and water is the prime objective. Rain-fed agriculture development in many, as you know, in India, 67% area of agriculture is cultivated through rain-fed or depends on rain-fed. So that in that area, conservation of water is a prime importance for agriculture or for crop production. So from the very beginning, watershed management programs were implemented in rain-fed regions. Third is agribusiness development in watershed. You are doing agriculture and other livestock and agroforestry systems. So there lot of opportunity to agribusiness is developing. So it provides the employment to the farmers, and so that holistic development could take place. That's why watershed development is known as a rural development program of the government of India, and it is one of the ministry, that's why it comes under the Ministry of Rural Development. It would also act as a platform for improving the technology on rain-fed and irrigated agriculture, livestock production, marketing, food and nutrition security, energy conservation. If we see what are the basic principles we are adopting in watershed management, you can say that we focus on utilizing and optimizing land according to its potential or according to its capability. Conservation of maximum possible rainwater at places where it falls. So within the watershed, you are having the higher elevations to lowest elevation. So some places runoff water moves fast, somewhere it get accumulated. So where it is getting accumulated or getting accumulation, there you can develop the harvesting site, and other places you can make the structures for conservation of water so that it can percolate in the ground, so that works as a recharge zone. Putting adequate vegetation cover on the soil surface which protects the soils from erosion during rainy season. Another objective is, or principle is, that draining out excess water, because all the rainwater you cannot collect, you cannot store. Plenty of water has to remove or go off in the streams. But while moving on the land surface, you reduce its velocity so that safely it moves from the land surface, so that it should not erode the soil. Maximizing productivity of per unit area and with per unit consumption of water. That's why watershed development programs, also we call it is per drop more crop. So maximizing productivity, preventing gully formation and putting nala, so gully erosions or where there are stream banks erosions are take place, there we do prevent gully formation further and control those gullies gullies to advance. Safe utilization of marginal lands. And in this, doing all these activities, there is a need to have a integrated approach. Integrated approach means you make a plan considering the geology, soil, land use, land cover, topography, and climatic parameters, rainfall, temperature, and other weather parameters into account, so that you can work towards management of soil and water. Therefore, you can develop the natural resources and you can protect that one, so that natural resources can be used on a sustainable basis for future generation. That's why your soil is a finite resource. If it get degraded, then these soils cannot be bring back. You know, the formation of soil is very slow. You can say 300 to 500 times slower than erosion. So if you will not protect the soil from erosion, then these soils get lost forever, and we will having acute shortage or acute problem of food, grain security to the country. If you see, and earlier also I have shown you that when in this the primary focus soil and water conservation, basically the problem starts with erosion, and erosion can be mapped on satellite data. So you see, I am showing here the Google Earth image where you can see the gully. These are the gully. Depression lands appear as a stream. So this is gully erosion is severe erosion, and adjoining area may be moderate erosion, or they may be witnessing your surface sheet erosion. And those features you can see in the natural color composite. It is not a false color composite. Green color showing the forest cover, but in the forest you see the density. Here the dark green, but here it's a light green. So here forest density is poor, and that's why you are getting more soil erosion. And you see that is where the density is poor, you are getting also the streams, linear features, irregular linear features. That is basically gully formation. This light color here in this area, this is the cropland, but this is the orchard land. Orchard, mango orchard, or you can say this orchard, you can see, you can distinguish from the cropland. So if you want to see the erosion, you want to interpret the erosion, then you have to see three parameters together. Topography means slope, vegetation cover, type of vegetation, forest or non-forest, density of vegetation, soil type, although it is very difficult, but due to the geomorphology, hilly landscape and plain landscapes, you can also assume some soil types. And rainfall, if area is witnessing high rains, then you can see the soil erosion. So these can be interpreted. I am showing the false color composite of that area. One area, you see, this is the Yamuna river. This is the river, a big river, and in this river lots of drains are coming, drainage are coming, but these drains are passing through the forest area. This is the dark red, bright red, you getting the very good dense forest, but in that also you are seeing the irregular linear features. These are the primary streams or first order streams, but these are also termed as a gully features. And these gullies get, if area is you are getting gullies, then the adjoining area must be affected by moderate soil erosion. So in the forest area also you are getting soil erosion. Here you see the agriculture land, crop land, and in this crop land you are seeing the linear features. These are the gullies. And here if you see the field size, this is the high resolution satellite data of 5.8 meter. Then you can see the field boundaries also, fallow fields with boundaries. But here if you see upper portion, the field boundaries fields are very close, so you are getting more smaller size of fields, but here the larger size of fields. It shows that is the larger fields means slope is less. If the field size is smaller, it means the slope is more, because farmers makes small fields in the higher slopes, although larger fields on the lower slopes. So topography can be interpreted from the remote sensing also, and fields, and you can see the gully erosion, and if gully erosion is there in these fields, then this area will be moderate erosion, and then problem comes that you need to conserve these gullies. You have to protect to further advancing of the gullies. Gullies should not advance, otherwise it will go beyond that one and it becomes wider, and that if becomes wide, then it will take most of the agriculture fields along these sides, that it means those fields you will lose forever. So we should need to protect, and remote sensing data is very beautifully, you can by visual interpretation, those features you can interpret it, and you can make a plan for this conservation plan for this area. So this area belongs to one watershed, and in this watershed that you can interpret various features: cropland, forest land, gully land, moderate erosion, and therefore you can make a land use plan. Here I am showing the same image, but showing that is suppose the linear features, that is the gully erosion, streams is coming towards the forest and merging here with this main streams. But you can see that is the gully or streams are so long, and these need to be conserved. Even in the forest area, you see these gullies, you can able to see that one. So again, the features you can see, even gullies depressional depth also you can perceive with the remote sensing data. If you see this satellite data, these are the hills covered with the forest, but adjoining area you are seeing the lot of streams, or they are the gullies. But this gully, suppose it is at this depth, it may advance to this one. Another satellite imagery where you are seeing that is the high resolution satellite data of Himalayas, higher Himalayas. You see the terraced field. This is on the satellite data, you can see the terraces very beautifully because of high resolution, and those terraces are fallow, no crops at this season. But here you can see the terraces fields have the some permanent vegetations also, tree, fodder trees or some fruit trees are there. So agroforestry system is there, but here pure agriculture. And here you can see no features of any terrace or agriculture. These are the scrub land or barren rocky area, barren rocky. But here you are not getting any field boundaries. You are not getting any terrace feature. These are the soils has been lost and very thin soils are left. That's why it is giving high reflectance. So those features, rock and barren rock outcrop area, you can see map. You can map the agroforestry cropped area, pure agriculture area where there is no tree vegetations are there. And these are the linear features are the channel or streams, you can say. How these appears, I want to show in this slide. That is, this is the terrace in the hills. You see the terraces here are slant, not perpendicular. Farmers made perpendicular, but over the period of time it becomes slant because of erosion. So this is unstabilized terrace, eroded terrace. But here you see the terraces riser are very 90 degree almost, no slanting. So these are the stabilized terrace. Can we see these terraces on the satellite data? Yes. You see here in the stabilized terraces you are getting the linear features. You can see the line. Here you can see the line. But Here you see, you are not able, it is, you are not getting any line feature. So here the unstabilized terraces was appearing like this one, but stabilized terraces are appearing like this one. So even high resolution satellite data, we can map the stabilized and unstabilized terraces. Why we want to see this one? Because this area, unstabilized terraces, requires soil and water conservation. We need to protect this land, because if we will not protect this side, then this field becomes wide, width becomes lesser due to erosion, and you will lose this agriculture fields forever. And stabilized terraces, they are very well maintained by farmers, and they need not a conservation measures. Always we have the limited resource, we cannot go for treatment of entire area. We want to find out which area requires more treatment, or first we need to we go for the treatment. So unstabilized terraces we need to identify. Even this satellite data, I can see the drainage line. These are the drainage primary first order stream, and they are merging together and going like this one. And you can see very beautifully the three-dimensional 3D view of the watershed. You can say from here the water is going this side, but from here top water will go this side. So watershed boundary, even in watershed boundary you can see ridge line, top of the hill. You can see very beautifully in this one. So these are the ridge line. So ridge line and stream drainage line, you can see this drainage line we need to identify for the conservation measures, where we can construct the vegetative check dams or stone check dams. So I will show you some figure what kind of check dams are there, or stream bank protection. These streams side are eroded, so we need to protect that one for further advancing, so that we can conserve soil and water. So with this basic, I will switch over towards the first land use planning for watershed. So for land use planning, as I told you earlier, we need to assess the potential of the land or capability of the land. This land is suitable for agriculture or suitable for forest. We need to identify. How we will identify using remote sensing and GIS, that part I will show you. How we do the land capability classification, there is two things is required. One is the land capability criteria. Criteria is already available in the literature or has been established by the scientist, researcher. These criteria we can take. Soil and water characteristics, land characteristics, when we are preparing the soil map, vegetation map, topography map, then soil and land characteristics map we can generate. And both the things we should match, and then we can get the land capability class. So land capability classification is a prerequisite or first most important thing. We have to prepare a land capability class map for conservation planning. It is a systematic classification and scientific classification. With these classifications, we try to identify or assess the potential of the land suitable for agriculture or cultivation or pasture and forest development. So in this capability classification, there are 8 capability classes are there, and these capability classes are numbered as 1 to 8 based on the characteristics. If your land comes under capability class 1 to 4, it means land is suitable for agriculture. But if capability class coming 5 to 8, then it shows that is land is not suitable for agriculture, but it is suitable for forestry and pasture land. Now you see, if you are getting capability class 1, it is land suited, best suitable for agriculture. But if you are going second, third and fourth category land, if it is there, then it is not much suitable for agriculture. It is, you can go for agriculture, but there is a severe problem of cultivation because of erosion. So class 4 class, if you go for agriculture, then you must go for permanent vegetation plus agriculture. So you can say you can go for agroforestry, or you can go for agrohorticulture or agro-pastoral system, so that you can conserve the soil and also you can take the crops in these lands. But first category soils and second category moderate limitation, you can grow any type of crop. But in these two, class 3 and class 4, you cannot grow all type of crops. You have to have limitation of growing few crops which can give the best canopy on the surface. When you go for suitability for forestry, so 5 is best suitable for forest, but 6, 7, 8, these lands are also not suitable for even forestry, because these very steep sloping lands, barren area, depth of soil is very less. So basically capability class 8 lands mainly belongs to the animal habitat. So so you can see, if we classify your land, your watershed into various categories, then you can go for land use planning. This gives you idea which area we should go for intensive agriculture, which area we should go for agriculture with horticulture or forestries, so that you can give mixed up to conserve the soil, and which area you should not go for agriculture. These are the land capability classes. How we do this one? Criteria is there defined in the literature. We see the texture of the soil, depth of the soil, slope of the land. You see the slope of the land, and erosion. What kind of erosion is there? Capability class 4, if you see, having the slope is 10 to 25%, and erosion is moderate. Even small gullies you will find. So small gullies you will find, so they are capability class 4. But when you are not finding any gullies, only sheet erosion is there, then you can say the capability class 2. And in this capability class 2, you need little management for erosion. Otherwise, means erosion is moderate, sheet erosion is there, so you need to have a good agronomic practices or cultivation practices. But here you can go for agronomic measures, but in this class you need to go for vegetative measures plus mechanical measures. Sometimes we have to do the mechanical things like making terraces, making stone patching, stone bunds. Here may be having simple soil bund, but here we need stone bunds. So these criteria, land capability class, be determined based on the texture, depth, slope of the land, erosion class. Then for each type of class, land capability class, you have a distinct criteria, and following this criteria we can find out the land capability. Now you see, for hilly area, for simplicity, FAO has suggested a different land capability classification system. He says that in the hilly area, soil depth is important and slope is important. Texture is not so important. So for sustainable land use planning, he says that if slope is gentle, moderate, strong, very strong, steep and very steep slope, and here is the depth, soil depth, because in the hills depth is the problem. If soil depth is less than 20 centimeter, he says that go for pasture, P. If soil is shallow, you can go for and steep slopes are there, you go for forest. If moderately deep soils are there and your slope is very strongly, because soil is also good, soil is there 50 to 90 centimeter, and so depth is but severe, here you can go crop with pasture, fruit trees, forest in that one, or you can go for cultivation C1, C2, C3. C1 means no limitation. If slope is less, any crop can be grown. But if it is C2, if it is slope is moderate and depth is moderate, then go for C2. Means cultivate, you can cultivate the land but with moderate limitation. Like that one, with simple classification, we can suggest that is which land we can go for, which type of land use plan. Now I will show you with some study carried out. This is the one watershed. Drainage map is there, and with seeing this drainage map, one watershed was classified into sub-watershed. For this watershed, using the remote sensing data, false color composite, this is the false color composite, we prepared the land use land cover map, where, because this green color showing forest area. So we found that is 11% area is under agriculture, the yellow color, rest of area is the forest, open forest or dense forest, and this area is the snow covered area. Then we prepared the slope map using digital elevation model DEM, which I told you earlier, and we find out 0 to 10% slope, 10 to 33%, 33 to 50, and this red area is showing having slope more than 50%, steep slopes. Adjoining area is your steep slopes, but red area is very steep. And also prepared that from the remote sensing data soil map units using soil landscape in analysis approach. So soil map was prepared. Then we prepared the soil erosion map using Rusley model, which I described you yesterday, and we find out that is this area, yellow color, this area is having high erosion, and this green color is having moderate erosion. So high erosion, moderate erosion map can be generated. Now what we did, we prepared from the soil map, soil depth map, and from DM we prepared the slope map, and both the map be integrated in GIS. We made the overlay analysis to prepare the land capability map using the land capability criteria, which I have showed you, that hilly catchment area, the capability classification system. And then we prepare this land capability classification based on land slope and soil depth. And you can see this one, with two map, we are able to get, that is this area, that is C1, C2, C3, C4, fruit trees or forest. So you see the blue area is showing, you go for fruit trees, you go for agro-horticulture, or you go for agroforestry, because these regions are having high soil erosion. So they cannot be put for pure agriculture. If you do practice pure agriculture, then there will be problem of soil erosion. So that's why this area has been identified based on your slope and soil depth and erosion map, that this blue area is getting high erosion and they are suitable for land capability class, capability C4, which is agro-horticulture and agroforestry. But capability cultivated land 2, if you see the red color has been shown that this land is suitable for agro-horticulture, and capability class 1, that is only this land, and this yellow it is showing it is suitable for C1, where you can go for intensive agricultures and need not require more management. So, land capability classification can be adopted for preparing land use plan of the watershed. And if you go for land use planning with this one, then you will use your land will be sustainable for future. Problem of erosion will be less and conservation of water will be taken care of because of vegetation in that area. Another another methods I tell you how to identify where to go erosion for soil and water conservation. So I will take the help of digital terrain analysis, digital elevation model, which yesterday in my second lecture I have described that one in detail. In that I told you that terrain indices are very useful map we can derive from digital elevation model, and this terrain indices gives a very useful and important information for taking the conservation plan. You see, this is I am showing you from the terrain parameters. One is that from DM you can make the slope map. You see the red color is showing the slope is very steep, red color is showing very steep, and green color is showing these are the nearly leveled or flat lands. And this map also you can DM you can also generate the your drainage network. So drainage map can be generated from there itself from DM, and you see here the drains are coming and meeting at this place. From DM I told you that is we can go for developing terrain indices. One is important terrain indices is terrain wetness index, TWI. As I told you earlier that TWI gives you information about the accumulation, runoff water accumulation area because of topography. So TWI we can generate from A is the up overland flow accumulation and beta is your slope. So using this DM you can generate your terrain wetness index map, and you see that is here the terrain wetness index is where you are getting the blue or black like there water getting accumulated, but the area where you are getting red, it means that area will not receive much water. These are the dry area, dry zone. So in the dry zone we need to conserve, we need to make some conservation measures so that water should not flow very high, so that you need to conserve their water, so you can make some pits or trenches in these lands. So terrain indices also helps you in identifying the site for water conservation. You see, this is the terrain wetness index map of that area, and red we have classified 1 to 4 value, means this red is the dry area, and this is showing the black area is showing value is 8 to 17, where is you are getting the high water accumulation, area of runoff accumulation, high moisture zone. So high moisture zone, low moisture zone and middle, so you can identify that where we should go for trenching, here we should go for stream embankment, and 5 to 8 this blue area is showing you can go for water harvesting sites, constructing water harvesting sites. So this terrain indices also helps you in identifying the location for water conservation. Another, I have told you in terrain analysis lecture that plan curvature and I told you that we can generate the plan curvature where you can do the convergence analysis and divergence analysis, and using this flow directional map you can generate, that is the erosion potential erosion risk area. Here I am not using Russley model, only because of topography which area will witness more erosion because of topography. Then we find that is this area, blue area, having the high erosion chances because of topography, because this area having very steep sloping, but this area is not having so steep. So it is having maybe witness E2 erosion. Here we are getting the E4 erosion or very severe erosion, and this area yellow color is showing that there we are getting almost no erosion or slight, very slight erosion. So erosion is slight, moderate, severe or very severe. On the basis of that our conservation plans vary. So we can plan the conservation plans. So these linear features what you are seeing here, these are basically the gullies. So here you need a moderate erosion, adjoining area is moderate, but the linear features you can see that is it is showing the gully erosion. So gully need to be protected, and adjoining area you have to go for a good agriculture management so that these fields does not get more erosion. So how beautifully terrain analysis can be done for conservation planning in watershed. I am showing some of the satellite data which even the resource set list for Cartoset Pan merge data on our Indian Bhuvan website, ISRO Bhuvan website. You see the data are so clear that these are the agriculture field, and for tree plantation or fuel and fodder trees are there. You can see how tree and fallow fields are appearing, and this area having the orchard. So how they are appearing, and this is the settlement area, village. So you can see very beautifully prepare the land use plan. You can find out where erosion is there or where erosion is not there. So you can characterize, suppose terraced croplands, you can see here. This is also terraced but agroforestry system. We can use UAV for as a promising tool for watershed planning. UAV, you can take the pictures from UAV, and advantage is that you are able to get high resolution digital elevation model, high resolution picture of the watershed. You see that picture is taken from UAV, the agriculture fields, how clearly you are able to see the croplands and fallow lands, and these are the forest land, and these are the fallow agriculture land. And even you can see the 3D view. We have made the 3D. You can see here that is the rain streams is moving like this one, and here the streams are moving and joining here, and this is the top of the hill which is flat, but flat of the hill's top is the agriculture cropland, but sides are scrublands or bushes. So there you will get the erosion, and you can see the small gullies are appearing. So you can identify by visual interpretation using high resolution image or picture. We have made the contour map of 10 to 50 centimeter, where you are making in the digital from satellite data around 10 to 20 meter, or in meters 10 vertical error was even 5 meter accuracy, but here you are getting 10 centimeter accuracy. So you can make a very beautiful digital elevation models or contour maps to analyze the terrain. So now I have shown you That is how remote sensing data can be used for interpreting the various features of erosion, various erosion classes, slight, moderate, severe and very severe classes from standard false color composite directly. I have shown you how high resolution satellite data, those erosion features can be mapped directly, and the UAV images also are nowadays being used for mapping those erosion features. So those erosion features can be mapped. And now I will I will tell you which are the conservation measures have been suggested for watershed management in the fields. So you can witness those fields and what conservation measures they are doing. One is that watershed management we do vegetative measures. Vegetative measures means where we do for crop or vegetation for conserving the soil and water. What you can do? You can repair your agriculture terraces. Field boundary, you can put the permanent grasses or bushes on the field boundaries so that it will protect the water from moving off the field, or it move water by filtering process so that sediment or soil will not be moved from the field, because we have to conserve the soil in the field itself. If it will move from one field, you know that field is losing not only the soils, but that field is losing nutrient also, because what farmers has put fertilizers or organic manures in the field, that will wash out along with the runoff water and along with the sediments. So you have to make a field boundary with the vegetative measures. You have to make the pastures, grasses, bushes. You go for horticulture, or where you are seeing the more erosion is there, class 3 and class 4 erosion. Class 3 erosion basically, you go there for horticulture crop plantation. New orchard, you make the area under the orchard so that it will give the whole the year protection of the vegetation. Your soil will be remain protected so that soil will not lost. In the class severely eroded lands, you go for forestry, because you can go for, because fuel and fodder is required for your livestock, and for home you need a fuel. But if you are not using fuel, but you can need those forests for fodder availability, because good quality of forest leaves enhancing the vegetative covers, then it will give a good food for your livestock, then your livestock will be well maintained. You go for fodder production, sometimes Napier grass are planted along the field contour lines, or you make the trenches and there in trenched sides you can make a fodder production. So by this one, and also in watershed management you go for preparing the rural connectivity, some small bridges, culverts, or some roads for reaching to the higher elevations of the watershed. What we do that one, you see, the terraced agriculture fields, croplands are there. These are well maintained, but side you see, this is the land which has been degraded. What we can do here? You can go for agroforestry or plantation, afforestation. Every village in the hills, 70%, 30% area is under agriculture, good agricultural land, but most of the area side of the agricultural lands are left and they are barren. If we do vegetative measures or we go for that, then we can stop the erosion from erosion. Here you see the farmers may put the crop residue, last year crop, that is stems and other leaves materials, he spread on the field surface, so that during rain these fields remain protected. So erosion will not take place, because rain will be, when rainfall is taking place, then it will not detach the soil particle. And in the row he has put the crop, so that crop will also come, and between the rows the open area will not be remain there. Here he has said that you do the contour cultivation, contour farming. Contour means joining the same height, land joining the same height. So you see the contour, he has made the crop, then fallow, then crop, then fallow, so that it will conserve the water. So what you can see, it will reduce the detachment of the soil particles. It will hinders or give the it will reduce the overland flow, velocity of the run of water, and because of that water will infiltrate into the soil, so less runoff will be generated. And if you are doing like these practices, then it will improve the recharge of the groundwater, and moisture will be retained, so that crop productions can be taken much better. You see one of the pictures here, he is doing agroforestry. Trees are planted along the bunds, and between the two trees, and this is the cropland, agriculture crops or food crops are grown. But here you see farmers are doing mixed cropping, maize plus legume, suppose urd, moong, those crops are planted between the two row. So this area is being cultivated for the legume, and this is the maize crop. So what is advantage, that you are getting double crop, as well as you are providing the protection to the land surface, so the rain water will not hit your soil, and your soil erosion will not take place, and water will pour on the from the surface to the land slowly, so it will infiltrate into the soil, so that water will not runoff will not take place, so erosion will be less. Here you see the agriculture fields. I was showing your bunds or terraces, you make the vegetation, here the grasses or shrubs are planted, so that this side of the terrace, we call it is riser, it remains protected, and here he is taking the crop. So if you will not protect this one, if you remove this one vegetation, then soil will lose from here, and then what will happen, the width of this agriculture field will be reduced later period. So you will lose basically your agricultural land forever. Here you see the bunds with grasses. These napier grasses are planted along the bunds, and this is the agriculture field. He is taking here maize crop, but here it is taking the paddy crop. So you can say very beautifully that maize is erosion permitting crop. Here erosion take place, and maize requires good drainage condition, but paddy requires water logging, water stagnation. But water should not come very fast, and drainage sediment should not come to this one, it should be there. So he is making the grasses, bunds with grasses, and so that by using this one he is protecting soil from erosion and protecting run of water accumulation, run of water velocity also, so that your soil will not get eroded. You see that grass plantation in the hills on contoured trenches. So trenches has been, first you make the trenches, this the hills having entire area no vegetation, all the soils have been lost, and no vegetation are there because water is not there, even grasses were not there. So maybe some of the mining activities or because of some other activities, this area lost the forest deforestation. They were, because this area is forest, but this area having no forest cover. So what, to regenerate, what has been done, that is the trenches have been made, and in trenches grasses were planted, and you see after 7 years the area, same area has been converted like this one. Now the vegetation has come. Now you put some trees, forest trees, and then it will be covered with the forest, converted into the forest land. So that by you doing this one, you are conserving the soils, or you have conserved these soils forever. So otherwise, if you have not taken, then these soils have been lost through washing. This is one of the picture which is a example of Nepal. You see, this was the hill conditions before taking the project. Degraded hills, trees were cut by the people, deforestation. Then forestry department with Nepal Swiss Community Forest Project was taken in 2011, and in 10 years, not in less than 10 years, you see that this area is converted into the forest land, and beautiful forest has come up. Otherwise, if you have not treated that one land, then it has been lost forever, because the soils will go eroded every year. Then comes that I discussed the vegetative measures. Now I am discussing you the mechanical measures, because the area which witness a very severe erosion, where rate of soil erosion is very high, gully erosion or gully eroded lands are there, gully formation has taken place, then you cannot do simply vegetative measures. You have to do vegetative measures plus mechanical measures. Mechanical means you have to do some trenches, preparation of trenches, some civil structure, some stone patching, like that one. So in this one, creation of new and improved irrigation facilities. What is the rainfed area is there, you develop the pond come under the mechanical measures, irrigation channels, irrigation tank. So these measures you can take, you can create, and this will serve, the water will be stored, and that can be used for irrigation purpose. Second is the water conservation, constructing trenches, ponds with embankment, means its sides should be protected so that it should not collapse. Pits, you make small pits in the forest area, so that their water will be stored, and that will slowly move into the hills, and it will recharge your groundwater. Plantation for regeneration of water resources, you do plantation then. Another is the drainage line treatment, vegetative check dams, stone check dams, crate wire check dams, retaining walls. There are various kinds of mechanical measures are there. I am not discussing all those measures, but important one which is taken care as a mechanical measures, which I can discuss here. You see that this is the check dam. Cemented structure has been put in the gully area, gully erosion. You make the series of check dams, so the water will be comes, and then it will be remain there, or sediments will also stop there. So sediment, depositing sediments every year, in 4-5 years or 5 years, you will find that these soils get deposited, and this get labeled land, and water is stored, holded there, so it will go into the ground, so that recharge will be there. Here you see that is the small check dams, that is cemented structures of the gully has been constructed. Here you see that is not the cemented structure, but only the stones are put into that one. Stones we can put in the bed also, check dam bed, that is gully bed. so that it will not erode further. You can see the beautiful pictures. These are the one gully. This gully, we want to stop the widening of the gully. Gully should not wide and erosion should be stopped. So this stones are crate wire. Crate wire structure has been developed. Small structure. And what will happen? Now the water will come, they will stop here, and all the sediments will be stopped there, and it will, soil will be protected here itself, conserved here. You see this gully, small gully has been plugged. So you can say the plugging of the gully. This is the stream, first order stream, which is taking lot of sediments, but if you stop the water, then you see the sediments now deposited here. So this is the stone and wire structure has been developed. We also call it is Gabion structure, on the name of scientist Gabion. And you see this is the Gabion structure, and wire with wire the stones, locally available stones you can put into that and you can protect. So you can say the agriculture field is there, and side of the agriculture field was getting eroded every year due to collapsing, land slipping, which I shown you earlier. Those things you can check here. You see that this is the hill, and these are your like a drainage. But this drainage line, if you want to conserve this hill, then you have to make the first the drainage line treatment. You have to make the Gabion structure stop the runoff water, and you have to do the afforestation on the sides. But before that, you have to do the trenching or contour trenching. This is the river, and along the river, you know, the stream bank erosion take place. So river bank protection, and many of the villages, you know, that is where rivers are flowing, they cut the agriculture field slope, agriculture fields flowing towards the adjoining area having the agricultural lands, and every year if you are not getting protected, this agriculture land will collapse and your agriculture fields area will be reduced. Here you see that is geojute application. This fiber geojute or jute bed is spread over the hill where the vegetation was not there, and you see, and then we spread some of the seeds of the plant or seeds of the bush or trees, then they get germinate, and primarily in beginning it provides the protection from the rainfall direct not hitting the soil, it is hitting the jute, so that its energy becomes reduced, so that runoff water will be less and soil will also not coming into direct heat, so detachment will not take place. So it gives the protection to the against the rainfall. And if you maintain this one, so in 3-4 years you will find that there naturally vegetation has come up, or some of the you make some of the afforestation programs over that, then those will remains go for successful. Here is using the local wood or that is your tree trunks, and make the structure like that one. We call it is crib structure, stabilization of steep slopes. So this area was the mining area was there, and after mining area was left. So it is the treatment of the mined area. You make the stones and make the use the sticks and control that one, so that your soil erosion will be protected and runoff will be reduced. So I have discussed various soil conservation treatments, vegetative as well as the mechanical measures which is being implemented on the ground. But where to do that one, those vegetative measures and mechanical measures? We need to assess the potential of the land. That's why I discuss you the land capability classification. You can generate the input parameters of land use land cover map, slope map, soil depth map, and using that map in GIS, giving the criteria, you can find out in watershed which land having capability class 1 or best suitable for agriculture, which is the not suitable for agriculture, that can be identified. So these are things are there. Now ISRO also maintaining ISRO Bhuvan portal, where watershed management program, as you know, the government of India, in every state there is a watershed management program is going on, and there's watershed management program now being monitored with the use of remote sensing and GIS, so that we can see that is how the watershed development program is progressing, and government of India want to monitor this progress, and they have taken the remote sensing high resolution satellite data for monitoring purpose. And tomorrow you will have a lecture from a speaker from National Remote Sensing Agency, uh, from NRSC, who will discuss in a detail how we are monitoring the watershed development programs of the government of India, and how the different watershed development programs have been generated or implemented on the grounds, and what are the conservation measures can be see with the satellite data. So all those details in a great details will be discussed tomorrow by guest speaker, that is Dr. T. Ravi Shankar, who is the group head and who has the who has worked a lot in watershed monitoring using geospatial technology. So tomorrow you will see that lectures, and now I say thank you to you all for joining this session, and I hope that these sessions must you have got some information about watershed management planning. Let us have a questions after 2 minutes. Thank you very much. Yes, question is that how land is the best suited for agriculture. Is any parameter? Yes, for agriculture suitability, I told you in this lecture land capability classification. In land capability classification, if your land falls in capability class 1, 2, 3, 4, 1 to 4, then they are suitable for agriculture, and the one is the best suitable for agriculture, and land capability class 4 is the marginal suitable for agriculture. So, soil depth, soil texture, slope, your erosion, these parameters are taken into account for assessing the capability of the land for agriculture. How can we control water and soil conservation due to remote sensing? Remote sensing provides you information that where land is degraded lands or eroded lands are there, or where the slope is more, where the vegetation is poor, where erosion is high. So, using remote sensing GIS, you can identify those areas, and in that area, you can go for conservation of soil and water. Can we get any idea about forest fire through watershed management? No. For it is not the technique for forest fire assessment. What is the role of FAO in watershed management? FAO is organization known as a Food and Agriculture Organization. It provides the technical manual, technical document internationally based on the international research that how we can go for watershed management program. So, and they show various case studies. So these FAO is organizations which provide the documentation. That's all. How can we prepare soil map? Soil map preparation from remote sensing data. I told in my first lecture that is we have to interpret the soil forming factors, or we have to interpret the geomorphology, topography, and land use land cover. Integrating these information which we can derive from the remote sensing data, we can prepare the land unit map that we call it is soil landscape unit. And in this soil landscape unit, you go take the soil samples, and those soil properties will be can be linked with those map units. In that way, you can prepare the soil map. How, why don't we use more UAV to cut cost rather than spending so much on satellite? UAV is costly one. Satellites are not so costly. Satellites cover the entire country, even the other parts of the country and other countries also. So it covers large area. UAV you cannot fly everywhere. UAV you can do for a small area, for your small project area. You cannot fly everywhere UAV. That's why satellite remote sensing have its own advantage, covering large area, providing detailed or high resolution satellite data. So UAV cannot, so that UAV is not very cost effective. Satellites are more cost effective. What is the difference between land use and land cover? Land use is when you are using the land for agriculture, then it is land use. But naturally the cover is there because of forest cover, then it is your land cover. Snow is lying over the land, that is, it comes under land cover. Streams are under land cover naturally, but when you are modified for agriculture use or plantation, then it comes under use, land use. At steep slopes, is bamboo plantation is very good as a vegetative measures? Sure, because bamboo plantation is one are used for conservation of soil resources and water resources in watershed management as a vegetative measures. Contour farming is possible in sandy soil like Rajasthan. No question. Rajasthan, we don't go for terrace farming. The way land in 3D mapping of the watershed you can do with any GIS software where digital elevation models can be analyzed. You can you can generate the 3D map of your watershed. So I told you QGIS software or ILVIS software, any software you are having, ArcView, ArcGIS, you can generate the 3D map of your watershed. Can you elaborate a bit on land reclamation? Soil and water conservation treatments are also known as a land reclamation measures. But land reclamations in generally we use this terminology for salt affected soils, where salts problem is there in soils. So how we can manage those salt concentration? Then land reclamation words commonly used. How to manage watershed? I told you this lecture was only to watershed management. So first you do the characterization of watershed. You characterize what is the topography, land use, soil, and using those informations you assess the erosion, which area getting more erosion, which less area. You assess the runoff water generation, which yesterday I described you in details, and all those informations we use when we are preparing a conservation plan for soil and water. What are the conservation measures are taken by Indian government? Government of India investing lot of putting lot of budget under watershed management program. I told you that that is Pradhan Mantri Sinchai Yojana, Pradhan Mantri Sinchai Yojana, today named like that one, but earlier it was IWMP, Integrated Watershed Management Program. Every state state governments are allocated money, and they and the district authority of the state identify that is the watershed, which the land, which area is more having problem of soil erosion. Then for that watershed they go for they characterize the watershed, and they suggest that is the conservation measures, involve the farmers, and they do all sort of mechanical and vegetative measures for conserving soil. So government of India putting lot of efforts for conserving our soils, and giving and benefiting to farmers for protecting their land. He has asked the people who live rural area and illiterate farmers are there, how they are doing the soil conservation. Actually, when watershed is selected in a district, in that watershed area, whatever the villagers are there, Gram Panchayat is involved, watershed development committee is formed, and in that committee they do the daytime 1 day workshop or many workshops they conduct in the village itself on the farmers field, and this demonstrate that is how the you can conserve soil and water. So illiterate farmers are also involved in that one, and they are informed, and they are demonstrated to learn all those techniques. How to check potential soil erosion risk? Potential soil erosion risk is, I told you, that is the technique or method to identify erosion risk area. And this erosion risk area, we can go for soil and water conservation techniques or measures. Can we volunteer for watershed development programs? It is not like that one. Watershed development programs implemented with the help of the farmers or villagers or local peoples. So the area where watershed development programs is being taken, those peoples are taken into account, are involved in that water conservation or watershed development programs. In my first lecture, I have shown you that is the budget allocation for watershed management measures. You can see, go to the Government of India website, watershed development, and where state-wise budget allocations have been put by the Government of India, that how much money they are giving to the each state and what programs are being done, and also the watershed development measures being taken on the ground, how we can monitor. Tomorrow in the special lecture where it will show that is the Government of India, how they are monitoring, because NRSC is doing regular monitoring on behalf of the Government of India. Is it possible to study soil parameter through satellite imagery? I told you the satellite imagery indirectly we interpret the satellite data to interpret the soil information. So you can say soil is a subsurface informations. Directly we don't get much information from remote sensing, but soil forming factors, for example, geomorphology, topography, land use, land cover, these three informations which are responsible for your soil formation. So these informations you can retrieve or you can derive from the remote sensing data and can use for the soil mapping that area having different type of soils. But on that area you go and visit and take the soil samples, so you can tell that this land area having this soil type. So remote sensing helps in mapping soil parameters or various parameters of the soils. How to measure the impact of watershed development on the groundwater? For groundwater, directly you are not getting, but if you are seeing, you can measure the groundwater table through in the well. You go and measure that because of recharge, groundwater table has rised or not. Or another is that if recharge has been taken place in the hills, then you will find the vegetative growth of your forest trees and vegetations will be very well, it will come, and from the remote sensing data we can study the vegetation conditions, forest growth condition. So like that, indirectly you can also measure the recharge and groundwater potential effect. In grit plugging, would not prolonged accumulation of soil obstruct water from passing through? Not like that one, because if you are making the stone plugging or grit plugging, so the holes are bigger size, and that water will flow, go off from there. Only sediments will be retained. But yes, if a lot of sediments has deposited, then you have to clean that one, or dig out the soils and spread over a nearby area. That management you have to take care. Apart from list 4, what other data we can use for soil erosion in a watershed? List 4 optical remote sensing satellite data provides a very good pictorial pictures of Earth surface, where you can see all erosion features. I think you go for the high resolution satellite data. What techniques would you suggest for halting the advancing desert towards Uttar Pradesh? That is a, you can say, uh, desert means in Uttar Pradesh it is not advancing. Desert is related to the scanty rainfall. So if rainfall is less, then you will get wind erosion, and that problem may come. So here we are not, I have not discussed that part. Um, Gully plugging is the important component of controlling soil erosion, because gully, if they are the gully in early stage, if you plug that one, its size is less deeper, it is less deep and less wider, so you can do very easily gully plugging, and then you can control the soil erosion. How can we control the soil moisture through soil conservation measures? Surely, if you are conserving the soil, runoff water is not moving fast, so you are allowing more infiltration of runoff water. Then your soil will be recharged with the moisture, so moisture will be conserved. So it is one of the conservation technique. Jute covering is a costly method to protect the land from the erosion. Apart from bushes, bunds is the bunds, is there any cheaper method? Jute is also not costly. It is being, because on the steep sloping area, jute are the geojutes are best option. You know, the soil is more costly than jute, so you protect the soil for future generation. So there are various methods and it has advantages. I am not recommending that everywhere you will go for jute, but the slopes, steep sloping area where nothing is holding in beginning or slope is very high, then geojute is the best option. Soil erosion study, how, what study area I choose, a watershed or sub watershed? It depends on the how much area you are going to address. So watershed, sub watershed is the based on the area. Can we measure the depth of a gully and what will be the accuracy? Depth of the gully, you need the stereo satellite data, where you can analyze by photogrammetric method. The depth perception also you can analyze. So there is a technique are there, which technique I have not studied there, but photogrammetric remote sensing techniques using stereo satellite data, high resolution stereo satellite data, we can measure the depth and width of the gullies as well. The soil and nutrition accumulation along the stones or other measures, how it gets graded to plain land again. Actually, you are conserving you are stopping the sediments, so sediment accumulation will take place, so that area will be reclaimed, and there you can go for afforestation. So that area you will get vegetative one. Otherwise, this gully is advancing, and these gullies will be lost the soils forever. So, but by stopping the sediments, your thickness of soil increases, and then you can go for afforestation or plantation in that area. How to overcome soil erosion with the help of remote sensing? Remote sensing is a tool and techniques that we use to identify the area where what kind of soil and water conservation measures should be taken under the watershed management program. Up to what spatial resolution satellite data can be get free? You know, I told you the Sentinel remote sensing satellite data of 10-meter spatial resolution, which is available free on the internet. You can download from the website Sentinel 2, Sentinel 1 data. Indian 5.8 meter, Indian satellite data, 5.8 meter is charged one, not free, but the charges are not much. It is very, it is not very costly data. So that but freely data is available, Sentinel and Landsat data, and Indian remote sensing satellite data, list 3 sensor data also going to be available free for the user. Okay, we can close it.